All right, we're looking at another algebraic method today. It's called elimination by combination. It's kind of fun to say, actually. All right, so in this method, most of the time you're going to see the equations already stacked, but if they're not stacked on top of each other, make sure you stack both equations, and you're doing it in like terms in columns. What form would that look like then? If you have an x over x, like down below here, what form is this in? Standard form. Okay, so you want to use elimination, and you want to set it up in standard form. Alright, now this is only a step if it's necessary. You might have to multiply sometimes. You might have to multiply equations. Could be both equations or just one of the equations. And what you're trying to do, if you have to multiply, is obtain opposite coefficients. But it's not always necessary. Always look. Okay, so right here, once you add this little thing in here, look for opposites first. Because if you already have opposites, you don't have to multiply. So look down here on the first example. Is there two variable terms that are opposite of each other?
Yes.
Which ones? 3y and negative 3y. These are opposites. Let's go ahead and mark that so we don't forget. They're opposites because they're different signs and the same number though, okay? All right, so if you have opposites like we have below, the next thing you're going to do is combine. You're going to combine the equations. What operation does combine mean? Addition. You're going to be adding like terms with the opposite coefficients, and those opposites will eliminate. And that's why they call this elimination, or also elimination by combination. You're going to be adding equations and eliminating at least one variable. Because now what's left is what you could solve for that remaining variable. So on our example number 1 down there, we already have opposites. So we could jump straight into combining these equations. So we're going to add these together. So 4x plus 2x is 6x. The opposites that add up, I'm only going to show this one time. That's going to be a 0y there. But you don't have to write that. And then there are constants, 16 plus 8, 24. So the 0y, we made that happen. So that's going to go away. 0y goes away, leaving us with a simple one-step equation. 6x equals 24. What's the answer? 4. Divide by 6 and you get 4 for that x value. All right, there's our x value. We're going to take that. The next thing we have to do is what we've done before in the previous method, and that's substitution. We're going to substitute that answer, okay, from the solving down there, 4, we're going to substitute that into one of the original equations. It's very important that you use the originals here. Eventually, we will be multiplying equations and changing them, but you don't want to use those changed versions. You always want to use the original in elimination. Okay, so we're going to take that 4, and we're going to go up here and replace the x in either equation. You can do either one. So it doesn't matter which one you choose. You can put it in either one. If you don't like negatives, maybe you'll choose the top equation. If you don't like big coefficients, maybe use the bottom equation. You'll get the same answer for y when you solve either one. Let's use the top equation here. So I'm going to rewrite 4x, but I'm going to replace that x with what I just solved. What was that answer I got? 4. We'll put the 4 in there. And then I have the other part of the equation still. Plus 3y equals 16. And now I'm going to solve for y. What's 4 times 4? 16. 3y equals 16. What's my next step? Subtract 16 from both sides. What do we get? Equals 0. Does that mean no solution? No, 0 is a number too. Don't discriminate. Now what? Divide by 3 to get the y by itself. And 0 divided by 3 is 0. Y is 0. So now we have both pieces of our solution. So now we're going to write this as a coordinate. Always x first. It was 4. And our y value we just got was 0. Okay, what key feature do these two lines cross at? 4, 0. What is that? It's x-intercept. That's right. We have one solution. And let's go ahead and be more descriptive at the x-intercept. That's pretty neat. All right, move down to the bottom one. Try this one on your own. Our paddle one practice. Do notice you already have what? Opposites. The opposites are where in this one? On the x. Those are opposites. All right, so we have opposites already given to us on the x. Okay, I like how this one is on the x's. It doesn't matter what's opposite. Get rid of it. Okay, it could be x or y. So we already have opposites. We're going to jump into our combination. We're adding these two together to eliminate the x. 2y and 4y makes 6y. 7 plus 5 is 12. Now we're going to solve this by dividing by 6. Y equals 2. Y equals 2. And once we have the y value, we're going to go back to one of our originals. Okay? Go back to one of our originals, and we're going to go up here and either replace this y or that y with 2 and solve for x. So let's use the top one. So 3x plus 2 times the y we just solved for, 2, equals 7. Again, that's the top equation, replacing the y with 2. Now we're going to solve for x. We'll have 3x plus 4 equals 7. Subtract 4 to get 3x equals 3. Divide by 3 to get 1. So there's our x value. Now the common mistake happens is if you are solving, you might get tricked to put the first thing you solve for first. But if it's a y, it has to go second in our coordinates. So the 2 is actually the y value that we got first, and then we got the x value after that. So this crosses at 1, 2 for one solution. Now let's go back up and see if we need to finish our steps. What's the last thing we could do with these answers to double check our work? Yeah, you can plug them in. You could test the solutions. You could test the solutions and see if they're right. It has to be true in both equations, though. Both equations. Not just one of them, but both. All right, now we're going to have to use that necessary step of multiplying. We're not given opposites. Let's look at the next example, number 3 here. And it's a good hint. They do say multiply, then add. But look, the x are not opposite exactly. The y's are not opposite exactly. They have different signs, but they need the same number, though. So which one's almost opposite of each other? The x or the y? X. The x is almost there, right? If I can make this 2x what? To make it opposite of negative 4x? Make it a 4x, huh? We will be multiplying by 2 to make that happen. So if you see that this one and this one have a like multiple, or think of like a like denominator, the like multiple is 4. This one's already at negative 4, so let's make this one positive 4. Eventually, we're going to multiply to make positive 4x.
Thank you.
Okay? That will be opposite of our negative 4x on the bottom equation. So to think about what do we have to multiply everything by to make 2x 4x? 2. So multiply everything by 2. There's my 4x. This one becomes negative 6y. This distribution will equal 8. We don't have to change the bottom one. Okay, it's already opposite there for us. But eventually we will have to multiply both equations sometimes. So rewrite it. Still positive 5y equals negative 8. Now we've made opposites. We are now going to combine our equations. Combination to eliminate the x. Add these together. Now we'll have negative 1y equals 0. Divide by negative 1. Do we get negative 0?
Yes.
No, we just get 0. Y is 0. Once you have the y, now we go substitute this answer in. But remember, go back to the original equation. We cannot use our changed equation here. Use one of the originals. So that means we're going to plug it in for either y value, this one or that one. Which one do you want to do? Top one sounds perfect. So top one is 2, whoops, wrong one. 2x minus 3 times the y we just solved for, and it's supposed to equal 4. So the 0 goes in there. That's our y value we just solved for. So 3 times 0 goes away, leaving us with a one-step equation. 2x equals 4, so x is 2. There's our answer. Another point of intersection that lies where? What key feature? The x-intercept. 2, 0. For one solution. All right, let's move to example 4. So in example 4, we're looking at, again, we're not given opposites exactly, but we do have opposite signs at the very least. So looking between 2 and 5, 8 and 20, what are the smaller numbers there? The 2 and the 5. So this should be our target to make opposite of each other. So what is the common multiple of 2 and 5? What bigger number can both of these fit into? 10. So we're going to make one of these positive 10x and the other one negative 10x. So it's a good strategy to go, okay, I want to make these opposites. So I know my opposite's going to have to be 10x and negative 10x to get this to happen. So I go, okay, well, the top one I can get to 10x if I multiply everything by what? 5. 5 times 2x gives me that positive 10x I'm trying to make. But I have to change all the equation. Multiply by 5 times 8y. 40y. 5 times negative 6. Negative 30. Okay, so there's our first part, positive 10x. And now the bottom, we want to get to negative 10x. So we write that down and go, okay, what do I need to multiply negative 5 by to get negative 10? Negative 2 would be a positive 10. Yeah. We want to keep that negative there, so we're going to use a positive 2. Positive 2 times negative 5 is negative 10x. And do that to the rest of them now. 2 times negative 20, negative 40y. 2 times negative 15, negative 30. We've made opposites, and now we go to combine, and what we tried to eliminate worked, but we also ended up eliminating the other variable. Okay, so all the variables go away, leaving us with nothing over here. 0. And does 0 equal negative 60? No. So when we go to combine and we see this not true statements, this is false. Please don't distract other people that want to pay attention. False. False means what? No solution. These lines do not cross. So that must mean that these lines are parallel lines. I spelled it right. Cruz doubts me, but it's spelled right. Nope. All right, the last one's on your own. Pattern 1 practice. You're going to have to make opposites down here. This is probably the hardest one of all the problems on the page because you're going to have to use a positive number and a negative number to make opposites here. All right, on the last example here, we have to make opposites on both of these. So we could use either the 20x or 20y. So we chose x in class. So what we have to do is think of what times 5x will give me 20x. Again, that's a common multiple between 5 and 4. That's how we chose 20. So 4 times 5 will give us 20x. So we'll multiply everything inside here by 4. So that becomes 20x plus 16y. And then 4 times 18 is 72. Last thing we do is now we're going to look at the other one. So what times 4x will give us negative 20? We have to use negative 5 down here. We'll multiply everything by negative 5. So negative 20x, negative 25y equals negative 5 times 18 is negative 90. Now we have our opposites on the x. Now we're going to combine these two equations and eliminate the x. Okay, so now 16 plus negative 25 will give us negative 9y equals negative 18. Divide by negative 9 to get our y value of positive 2. So once we have that, let's go ahead and put that in our coordinate for solution so we don't get confused. That goes there. Now we have to take that y and go back, remember, back to the originals. Either one of these y's can be replaced so we could solve for x. So let's go ahead and do the bottom one there. 4x plus 5 times 2, the y value 2, equals 18. So simplify, that becomes 4x plus 10 equals 18. Subtract 10 from both sides. And then divide by 4 to get the other answer, 2. So 2 is our x value. Again, when we have a solution of a coordinate of xy solution, it always means we have one point of intersection. All right, may the math be with you.